Now, starting with figure 03, these parts used to take almost a week to produce with just one CNC machine. But now, thanks to our advancements, it only takes 20 seconds, which is truly remarkable. Greetings everyone, this is Era speaking. I am thrilled to share that Figure AI has inaugurated its state-of-the-art manufacturing facility, botQ, which is capable of producing an impressive 12,000 humanoid robots annually. Right now you are looking at the Figure 03 model. The 02 model has been revealed, and the lessons learned from its production have been incorporated into the AI system. This has refined the manufacturing workflow, enhancing the layout and timing for each phase. By optimizing pipelining and maximizing parallel processing, production efficiency has been greatly increased. This approach is reminiscent of the strategies employed at the Tesla Giga factory. It has become a huge system. This led to the creation of botQ as a product. Similarly, AI has been integrated into the optimization process, whether it involves key assembly tasks or embedding it into logistics processes, which closely resembles Tesla's approach to manufacturing electric vehicles. It would be interesting to see which parts were optimized. The announcement was made on March 15th. We're talking about a production system capable of handling large quantities. We use factory to sound impressive, but there's a reason we stress high volume here. To lower the cost of humanoid robots, production must be highly automated and in large quantities. The industry believes that the success of humanoid robots won't end with just a few units sold, so productivity can be a competitive advantage. Optimization at the factory level is essential. As I mentioned before, we are aiming to manufacture up to 12,000 humanoid robots annually. This will be our first generation production line, and we expect even greater enhancements with the next generation of factories. Similar to how Tesla overcame its production challenges and set a new benchmark, we believe we can achieve comparable milestones. Following that, companies like Shara started to replicate Tesla's factory system quite closely, which allowed them to roll out vehicles such as the SU7. So, instead of just copying, they redesigned the entire production line and changed the production architecture, similar to how changing the architecture of a CPU or GPU leads to more efficient structures that can't be achieved by just increasing the clock speed, allowing continuous advancements in CPUs and processors. Similarly, within this manufacturing facility, the arrangement and optimization of each interacting element determine how quickly and how much can be produced. Since Tesla demonstrated this approach, innovations in manufacturing facilities have been taking place, especially over the past 8 months, which is a very short period. During these 8 months, the hardware and manufacturing engineering teams at Figure have been diligently working on creating a manufacturing process that is both efficient and highly scalable. In this process, they have adopted a vertically integrated approach. They opted for vertical integration, deciding to handle all quality control and manufacturing management internally. When you bring in external partners, various margins keep adding up, so we avoid that. When we work with partner companies, each one tends to build in their own safety margin, which can accumulate unnecessarily. This can result in a decrease in efficiency. Consequently, it seems that we are also aiming to emulate Tesla's vertical integration approach to reap similar benefits. Furthermore, in terms of software infrastructure, systems like MES, PLM, ERP, and WMS are crucial for establishing a well-functioning factory environment. Ultimately, the goal is to create a system where robots build other robots. It would be intriguing to delve into the specific areas that have been made more efficient. Here's the video you saw earlier. The roadmap points to ongoing enhancements. Essentially, they have been rigorously testing the Figure tool to determine the optimal site for its production. There can be delays in different stages of production, whether it's creating actuators or sensors, and there are also specific stages dedicated to the final assembly of these parts. There are several steps involved, and some can be performed simultaneously. Additionally, there will be processes dedicated to creating various types of sensors. There are various times involved in making the axis, and each manufacturing period will have different production times. By optimizing numerous parameters overall with AI, the cost function was minimized in terms of time. This is because the Figure 02 has many components, making the manufacturing process quite complex. The assembly time is remarkably impressive, and with Figure 03, we anticipate achieving high-volume manufacturing capabilities. A striking example of this is the efficiency in producing these parts. In the past, it used to take almost a week with a single CNC machine to produce these parts. Now it only takes 20 seconds. It's almost unbelievable, isn't it? It makes you wonder if there's some kind of hidden secret behind it. From the start, they didn't optimize the process for Figure 03. Some machines took a week to complete tasks. Initially, without considering mass production and just making a few units, factory optimization was not done at all. When comparing this to the current setup, where the process has been reduced from a week to 20 seconds, it makes sense. Otherwise, the difference would be too significant. The CNC mentioned here is nothing special, it's just computer numerical. Control, which is where we pre-code the actions we want to perform on the computer. By pre-programming the desired movements into the computer, the machine can automatically control the process, allowing us to complete sequential tasks that would normally take a long time in just 20 seconds. This method, which has been widely used in the production of automotive, aerospace, and mechanical parts, involves a process commonly referred to as complex steel molding. We're talking about the method of molding steel, which includes various techniques. For example, injection molding, which in Korean is known as sachul or injection. Imagine melting plastic and pouring it into a mold, then letting it harden into the desired shape. This process is known as injection molding. Die casting, as you might know, is a process where metal is melted and then used to create various parts by pouring the molten metal into molds. We see a lot of stamping equipment. It's all about applying intense pressure. Whether it's pressing or cutting, the goal is to use immense force to slightly trim or shape metal sheets. This is what we mean by cutting them out. Creating something like this requires bringing in the equipment. This involves significant initial investment, but it will happen quickly. This indicates a strong belief in their investment, and their promotional activities reflect this confidence. Now, let's talk about the highly accelerated life cycle test. What is it exactly? When we create a humanoid robot, we need to determine its lifespan. To find out, do we have to keep the robot running until it breaks down? Well, that's one possible method. But in reality, quality control and testing before mass production are similar to semiconductors. By intentionally exposing the components to extremely high temperatures, we can analyze how quickly the charge depletes, how the characteristics change, or how the current flows, allowing us to conduct rapid tests. So, when they mention using high-temperature ovens or dedicated actuator tests or failure analysis increments, it indicates they are performing in-house tests to assess the durability of the humanoid robot. This practice is a distinctive advantage of Figure AI, as such extensive testing procedures are not typically employed in manufacturing facilities. Otherwise, if LG guarantees a fridge for 10 years, do you have to wait 10 years for a new model? That doesn't make sense. So we conduct accelerated life tests. We are well prepared for it. That's what I wanted to mention. But when it comes to vertically integrating humanoid robots, it's somewhat unavoidable. This is because the core technologies of humanoids are essential. For example, our backsteering hand or the battery. Though there are quite a few batteries, actuators and such are new to the robotics field. We need to collaborate with many existing small and medium-sized suppliers and parts manufacturers, but the supply chain is still not strong. So they often end up ordering key components themselves. They are also directly managing the actuators and the movements of the hands, and in doing so, they are establishing their own supply chain. By building this comprehensive ecosystem, their objective is to achieve substantial advancements within the next 4 years. We will expand to 100,000 robots and actuators. We aim to expand to 3 million units. To achieve this, we are currently establishing these supply chains. For example, take a look at this. They handle battery pack assemblies along with a variety of other components. Their heads and hands are made and need to be assembled. Processors must be installed, along with other processes. And there's also an engineering office. They carefully analyze the movement patterns and time required for each task to optimize everything, using tools like Product Lifecycle Management, PLM, and Enterprise Resource Planning, ERP. But to be honest, when I look at this, it feels a bit like a startup, somewhat lacking in sophistication. In this setup, the operations at the factory level are seamlessly integrated and extensively utilized. Particularly in the semiconductor industry, it is common practice to manage products by leveraging their life cycle, which naturally leads to decisions about how the entire factory should operate and produce. We enhance the efficiency of both the assembly process and the overall system. While it might seem like a minor detail to emphasize, it's actually quite impressive when you consider that we are transitioning from a startup to a full-fledged manufacturing facility. This expansion phase signifies a significant milestone in our journey. From the perspective of creating a massive factory system, just as numerous traditional car manufacturers have adopted these processes, our startup, Figure AI, which is developing humanoid robots, will also implement systems like MES and ERP to build a large-scale manufacturing enterprise. And of course, robots will be making other robots. Recently, Figure AI unveiled Helix, a system that allows robots to work together using a unified AI model. This model includes systems 1 and 2, enabling robots to interpret external inputs and perform different actions. At botQ, they are investigating how Helix can be leveraged to improve the manufacturing process by facilitating robotic assistance in various tasks. This goes beyond just tidying up your fridge at home. We're discussing collaborative models within the factory environment. So we are continuously reviewing the aspects needed for production at Figure's botQ factory. Conveyor systems, also called Ford systems, revolutionized the car industry. In the past, building a single car used to take several days of dedicated effort, but with Ford's conveyor belt system, mass production sped up significantly, making cars widely accessible. Similarly, humanoids need many sensors and AI models. Mass production must be fast and cost-effective for them to become mainstream. Consequently, it's clear that Giga, a company anticipated to become a leading player in humanoid robotics, is expanding its factory operations from a startup to a major enterprise. While Tesla has yet to announce specific production goals for their facility, their vast experience in mass-producing electric vehicles can be directly leveraged for the large-scale manufacturing of humanoid robots. Following that, Tesla has advanced the technique of gigacasting, which enables them to shape metal components in a single molding process. Here, you see footage from Giga Berlin. Various equipment is in action, with parts moving as a single unit. They are pressed and shaped into form. Take the unibody system of the MacBook, for example. It usually requires dozens to hundreds of different parts, but with this massive equipment system, it can be done in one go. This significantly reduces the process. This means we save time. Of course, Tesla does not make all the Giga testing equipment. Tesla got this Giga press from a company called Idra. It's an Italian company. The presence of such equipment makers shows the demand. When Xiaomi introduced this technology, they called it hypercasting. So, by following that and making the parts into one large module at once, they quickly produced electric cars, didn't they? Of course, safety is also important. These advancements require specialized knowledge, and they sometimes face criticism for stability issues. If humanoid robots were to enter mass production quickly, having one at home might feel quite odd. However, this progress is happening faster than anticipated, and Giga AI's factory tour underscores the importance of these innovations. We have some high-quality zip-up hoodies perfect for spring. Whether you are a graduate student or looking for group attire, please take a look and show your support. To wrap things up, don't forget to check out our Instagram for swift updates and concise information from Era. Stay informed with our quick posts. This has been Era.